Uh, okay. Hello, guys. Hello, everyone. Thank you for joining today. We are students of Batch 7 AIML course, and we are doing it by the IIT Delhi. And this time we are basically uh, we are basically making our foundations of the maths part of the machine learning. So that's our agenda of today, to understand what is linear algebra and how does it contribute to our machine learning learning path. And we'll try to understand this one thing, what is linear algebra and how does it relate to our uh, machine learning models, right? Okay, so for that matter, I have created a document for everyone, so that we can follow along, and we'll try to understand each and every part about the linear algebra. Okay, so before proceeding further, I just want to show one thing, that is foundations of machine learning picture, right? I just want to say one thing. So machine learning is based on this is how machine learning or deep learning is related all together. So machine learning, we have discussed about machine learning in our last session. So machine learning is basically uh, trying a system to teach a pattern so that it will predict the next value, or it can predict our desired outcomes. We'll we Machine learning is a technique of computer science and engineering, where it helps to build a system which will predict the desired outcomes. And that machine learning is totally based upon these four pillars. So these are the main things that is all about. So probability and statistics comes into the picture, where when we take the data, when we talk about the data, that is all about the statistics part, how the data distributions are, and what is the variance, and like further and so on, and further there are many things about the statistics. And there is a calculus part. So calculus is basically a stream of mathematics where we perform the differential equations and integrating and differentiating equations. But what are we differentiating or integrating? So we are differentiating, integrating the vectors, right? So vectors is something our whole calculation that we are differentiating or integrating are totally based on the vectors, and vectors are nothing but just a representation of our data. So a column, we can imagine as a vector. A column in a database, in a table, can be considered as vector. Okay. So today we are learning about this linear algebra part. How does it work? So altogether, this makes machine learning, and machine learning, deep learning is a subset of machine learning, where we specialize about NLP, natural language processing, and further on, right? So that was all I wanted to do before going to the document. So we understand that linear algebra is a very important part of machine learning, to understand the equations. And so that linear algebra is the branch of mathematics that deals with vectors, matrices, and operations on them. So there can be a lot of definitions out there that we can read about linear algebra. This is the definition where I am only considering everything. I'm teaching everything about linear algebra related to machine learning only. The document is prepared in a way where we relate everything with context of machine learning, because we want to understand linear algebra We don't want to PhD in linear algebra. We just want to understand how this is related to the machine learning. So so linear algebra is the branch of mathematics that deals with vectors, matrices, and operations on them. Right. Linear algebra is the branch of mathematics that deals with vectors, matrices, and operations on them. Right. Practically in machine learning, vectors represent data. वेक्टर्स मैंने आपको जैसे बताया कि वेक्टर्स जो होते हैं वो बेसिकली डेटा होते हैं. वो डेटा डेटा कैसे होते हैं? राइट. लाइक जैसे मैंने आपको बताया कि कोई भी टेबल में एक पर्टिकुलर कॉलम यू कैन कंसिडर एज अ वेक्टर. ओके. Matrices represent collection of data. So matrices are the like multiple columns of vector together. So matrices are the collections of data. राइट. सिमिलरली मेट्रिसेस जैसे हमारी डेटाबेस में हमारी टेबल्स होती हैं, सेम वे आप इमेजिन कर सकते हो मेट्रिसेस के बारे में भी. बट हेयर द कंटेक्स्ट डिफरेंस वील गो फर्दर. Linear algebra tells us how to combine, compare, and transform data efficiently. In machine learning context, vectors represent data. मशीन लर्निंग में vectors जो होते हैं वो डेटा होता है बेसिकली. हम डेटा को बेसिकली कन्वर्ट करते हैं वेक्टर में. दिस इज व्हाट इट मीन्स. वी कन्वर्ट डेटा, we convert our data into vectors, right, to perform machine learning. And matrices represent collection of data, right? तो मतलब collection of vectors, right? collection of vectors. Okay. And linear algebra tells us how to combine, compare, and transform data efficiently. This part will come later. What does it mean? How to combine, compare, and transform data efficiently. We will come to this part. Okay. And how to think about linear algebra. Forget symbols for a second. हम एक बार को linear algebra में symbols को एक बार को हटाते हैं. हम normally समझते हैं कि linear algebra क्या मतलब है. ठीक है. तो think of machine learning as a high dimensional space. एक हाई डायमेंशनल स्पेस ऑफ वेक्टर्स होता है. राइट. एक हाई डायमेंशनल से मतलब क्या है? हम जितना इमेजिन कर सकते हैं डेट वी कैन ओनली इमेजिन लाइक R3 ऑफ स्पेस. R3 ऑफ स्पेस. लाइक हम सिर्फ 3 एक्सिस पे सोच सकते हैं और ये हाई डायमेंशनल स्पेस होता है.
Hello, Himanshu. Just wanted to add a thing in vectors only. That vectors are like order. They have an order. Like they are a sequence of data. Whereas a scalar data is just a single data without any order or like sequence.
लाइक राइट.
Yeah.
इट्स अ सीक्वेंस ऑफ डेटा. बिल्कुल. इट्स अ सीक्वेंस ऑफ डेटा. राइट.
Yeah, that's it. That's it.
Okay. And each data point is a position in space. Each data point is a position in space, right? Each feature is a direction. Okay, so let me show you visually. Satyam, okay. Satyam, can you show? Okay, I'll go. Okay, we all know this is our. Right. So we are talking about how to think about linear algebra. Forget symbols for a second. Think of machine learning as a high dimensional space. Each data point is a position in space. Each data point is a position in space, like in this Cartesian plane. if I want to get the position of this point, I will say what is the position of this point. uh, like we can do, right? हम x एक्सिस पे इसका कट लेंगे, एंड हम y एक्सिस पे भी इसका कट लेंगे, एंड देन वील गेट द पॉइंट, हमें ये पॉइंट मिल जाएगा. ओके मैंने यहाँ पर एक इमेज आपके पास पहले से तैयार की हुई है. लेट मी मूव फॉरवर्ड. Okay, each data point is a position space. Is a position in space. Each feature is a direction. A model is rule for moving through space to make direction. ठीक है. Each data point is a position in space. Each feature is a direction. Each feature. Feature माने एक कॉलम. Feature माने वेक्टर. Each feature माने हमारा वेक्टर, राइट? हमारा एक वेक्टर. हमारा हर एक फीचर एक वेक्टर की रिप्रेजेंट में शो होगा, राइट? मैं अभी आपको दिखाता हूँ मैं कैसे बताना चाह रहा हूँ. लीनियर अलजेब्रा इज द मैथ दैट लेट्स अस रिप्रेजेंट पोजीशंस उन्हीं वेक्टर्स की, उन्हीं हमारे डेटा की, मैप वन स्पेस टू अनदर, मेजर डिस्टेंस इन सिमिलैरिटी, रोटेट, स्ट्रेच एंड प्रोजेक्ट डेटा. ये सब हमें हेल्प करता है. लीनियर अलजेब्रा जब हम पढ़ते हैं तो हमें ये सारी चीज़ें वेक्टर के बारे में पता लगती हैं जो हमारे डेटा पॉइंट्स हैं, कि एक तो उसे डिफाइन करना, दूसरा वो स्पेस में कहाँ पर है, उस लाइक उसे मेट्रिसेस ट्रांसफॉर्मेशन करना, उसे मेट्रिसेस फॉर्म में कन्वर्ट करके एंड देन एल्गोरिदम अप्लाई करना. फिर उसके बाद ये भी मेजर करना कि वो एक दूसरे से डेटा पॉइंट्स कितने दूर हैं, कितने सिमिलर हैं. लाइक इन द कॉन्टेक्स्ट ऑफ एनिमल, बॉय और कैट में सिमिलैरिटी कम होगी, बॉय और डॉग और कैट में सिमिलैरिटी ज़्यादा होगी. तो वो सिमिलैरिटी फाइंड करने के लिए we'll go we use linear algebra. That's why how we use linear algebra. Hello Bhageshri. Okay, in other words, linear algebra is a geometry for data. Even with the data lives in 10,000 dimension, मतलब we cannot visualize like beyond R3. R3 यानी 3 axis, 3 axis space. We cannot imagine after that. तो लीनियर अलजेब्रा हमें हेल्प करता है. और वो जो डायमेंशंस होती हैं, वो डायमेंशंस जो हम एन डायमेंशंस यूज़ करते हैं वो फीचर्स की डायमेंशंस होती हैं. तो लेट्स से अगर एक मॉडल 1000 फीचर्स का यूज़ करता है, तो यानी कि उसके अंदर 1000 डायमेंशंस पे पैटर्न्स ढूंढ रहा है वो मॉडल, 1000 डायमेंशंस पे. तो वो हम विजुअलाइज नहीं कर सकते हैं. तो वो हम समझने के लिए लीनियर, या ये कह लो कि हमने यहाँ से उसे प्रोड्यूस किया है, राइट? तो जैसे फॉर एग्जांपल दिस लीनियर रिग्रेशन मॉडल. सो लीनियर रिग्रेशन मॉडल इन दिस पिक्चर, this blue line is our model. This blue line is our model, and the x-axis represent the size of the house, and the y-axis represents the price of the house, and the crosses are the data points in the training data sets. And through this data set we regress a model, and then we get a straight line, this blue straight line, as our model dot predict. Then when we use, so when we use model dot predict, the model gives this straight line in this linear regression model. So let's say if I want to find out, the model is trained now, the model looks fine also, the losses doesn't seem so bad, I think the model is good for this data. And then when we give him when we give it a new data, a fresh data, like a list of features. This is only one feature, like the size of the house. And let's say I'm giving it the size of the house, number of the rooms, the locality, number of bathrooms, floors, dining area, carpet area, like many features, interior design, मैनी फीचर्स. और जब मैं उसे नया डेटा देता हूँ कि भाई मेरा घर ऐसा ऐसा दिखता है, ऐसा ऐसा होता है, उसमें ये सब सारी चीज़ें हैं, जो भी मॉडल के जो भी फीचर्स की रिक्वायरमेंट है वो सारे मैंने उसे दिए. तो जब मैंने उसको वो सारे फीचर्स नया डेटा दिया, तो वो मुझे उसका प्राइस प्रिडिक्ट करके दे देगा कि भाई तेरे घर का प्राइस मेरे हिसाब से इतना होना चाहिए. जो कि वो काम करता है एक प्रॉपर्टी डीलर या फिर कोई रियल स्टेट एजेंट जो काम करता है, वो एक हमने मॉडल से करवा लिया. So the point in context of linear algebra, these are the vectors. So we have a vector of size in feet. Okay, let's move forward. Mathematical formulation. At the heart of linear algebra are a few building blocks. So we have scalars, we have vectors, and we have matrices. Scalars माने single numbers, vectors order list of numbers, like a list जो हम पाइथन में लिस्ट यूज करते हैं. एंड मेट्रिसेस आर द ग्रिड ऑफ नंबर्स. सिंपल, नथिंग टू कंफ्यूज विद. matrices are the grid of numbers, vectors are the order list of numbers, and scalars are the single numbers. Example of a vector is x is equals to 2 4 6. This is a vector. This can represent the size of the product. So we can consider this as a input feature. So this input feature is a vector. X is equals to a vector of numbers, an ordered list of numbers. Why
Uh,
ordered?
Hello, Himanshu. Just want to add something on linear algebra only. Uh,
Mm-hmm.
it provides a framework for understanding concepts like line, planes, or higher dimensional spaces. S- I just don't know about like how it is related to data. And today, when I was reading about linear algebra, I got to know about if we are considering line, planes, or 2D or 3D data structures as a data, then we can relate to it. Then we can relate how linear algebra is related to machine learning. If we are taking line as a set of data points and plane as a 2D set of data points, like matrices,
Mm-hmm.
and like maybe in a 3D form, maybe a tree or a like forest,
Mm-hmm.
then we can like relate to it. Like then we can like relate linear algebra to machine learning. I was like today I was like very fond of this thing about like how linear algebra is directly proportional to machine learning. Then I got to know about this. Just wanted to add my knowledge. That's it.
Okay. Thank you, Satyam. And so mathematical formulation. If we talk about mathematical formulation, we have scalars, we have vectors, and we have matrices. Right. So example of a vector I have already explained, like this is the input feature. So this is one feature. And we have, okay, so we'll go forward. Now let's take a real world example shown in the picture above. A house predictive value. Suppose you have a data set of house prices with two features, size and number of rooms. One house can be represented as यानी कि वन हाउस यानी कि सिंगल डेटा पॉइंट can be represented as in the plane of it can be represented in the plane of two dimensional space, where the primary axis represents the size and the secondary axis represents the uh, number of rooms. This can be considered as a single data point. 5 houses together form a matrix. So that's one data point, and that's 5 data points. That's how we store 5 data points in the form of matrices. Why are we converting it into the matrix? I will come to this part later. So I have already shown you to, like, in linear algebra there are basically three things that we need to work with. First are scalars, second is vectors, and third is matrices. Okay, so scalars are the simple single numbers. We can understand scalars, we all understand scalars. Vectors are the numbers, order list of numbers, and matrices are the grid of numbers. So basically a grid of data point. This is the matrix. And so that's how linear algebra is organizing raw information into something models can work with efficiently. Connection to machine learning. Data sets are matrices, data points are vectors, data sets are matrices. Right, now we can understand this, why data sets are matrices. Why? Because I have shown you the example of 5 data points together. It forms a matrix. Let's say a model has 1,000, or not 1,000, let's say 10 features. Let's say we have 10 more features to describe a data point. So then it will be a dimension. How many dimension will it have? 10. 10 cross 10 cross n cross 10. The matrix will be the matrix, the x feature, the x that we give input to the machine learning model is actually a matrix of n cross 10, where n is the number of the records and 10 is the dimension, row into column. So that's why we convert this into the matrix form, right? So connection, data sets are matrices, data points are vectors. So every data point is a vector. We will come to the vector part, don't worry. Model parameters are vectors and matrices. Model parameters vectors भी हो सकते हैं और matrices भी हो सकते हैं. And predictions are matrix multiplication. Right, so prediction कैसे होता है वो मतलब, like, I have put this in a very simple form, but even if you in one of the video of Andrew Ng sir, he has also said, if you, like, someone asked him like how much linear algebra it requires to understand machine learning, he has said like you only have to understand the matrix multiplication part, the matrix operations, right? If you understand the matrix operations, then you can pretty much understand the whole mathematics. You can make sense of the mathematics, if that's anyone's goal. So predictions are matrix multiplication. Yeah, I want to bold this. Okay, neural networks are stacked linear transformation with non-linearities in between. So we don't talk about neural networks here. We are way beyond this. Example: y is equals to mx, y is equals to wx or xw. This is a model's equation where y is the target output and x is the input feature and w is the weight or the scaling factor, we can call it anyways. Common misunderstandings. Linear algebra is only for, these are the common misunderstandings of linear algebra. Linear algebra is only for linear models. Linear libraries handle this for me, so I don't need it. And the last misunderstanding, it's all abstract math. This is not true. Summary: linear algebra is the math of vector and matrices. It provides structure to data in machine learning. It provides structure to data in machine learning. Every model uses it under the hood. And understanding linear algebra is important to tell why a model is giving wrong predictions. So let's say you have understood how to set up a model, and now the model is giving you the wrong predictions. You cannot improve the model without understanding the equation behind it. In a legacy predictive model I'm talking about, so like many people are understanding models as like large language model that is currently going on in the market, That is it's a natural language NLP model, and it is basically trained on a very large data set. And the way the attention research paper is implemented, like the model is behaving like a person. It's a generative AI model, and the model that we are trying to understand here are the simple models that has been going on in this industry for a very long time. So in every model, even if you are using generative AI models, let's say you are training it with the wrong your model is not behaving as it should be. You have trained the model to give it some context to retrieve any information from the context, but it is not giving you the right answer, even if you have provided the context with the right technique. So that's where the algorithmic part comes up, or the new research papers also comes up, like how to get that model getting the best answers. So that's different part, but linear every model works with the linear algebra. The equation behind it, we can understand it through the linear algebra only. What's next? We'll start with the basic building blocks of linear algebra, right? Scalars and vectors, representing vectors, vector notations, indexing in vectors. So foundations of vectors. Scalars. A scalar is a single numerical value, often representing magnitude and quantity, right? In ML, loss function, learning rate, bias terms, and regularization strength, etc., are all scalar values. Like, right? Scalar may look boring, but in ML, they control scale, sensitivity, and stability. So if the vectors, so if vectors are the data, scalars are the knob we keep turning until the model behaves. So what I mean by that is, scalars are the single numerical value. Like in linear regression model, we have a hyperparameter called alpha, which is a learning rate in the used in the gradient descent algorithm. So there we provide a value of alpha, that is a scalar value. So a scalar is a single numerical value, often representing magnitude and quantity ki kitna. So machine learning is basically, we can refer this as a cooking also. Very good example. We can take let's say we want to create a new model for some use case of for our client, and we have everything that we want in our kitchen. So he has ordered some recipe. So here the recipe is we take the problem, and we consider like what kind of model that we use. So we let's say it's a predicting a numerical value problem, so we use linear regression model. So there, when we use these models in the algorithms, we have scalar values. For example, learning rates, or let's say what is the loss of the function, that is also a scalar value, right? And so basically they are in cooking example, they are basically नमक मिर्च तो डालना है, लेकिन कितना नमक मिर्च डालना है कि स्वाद अच्छा है। तो मतलब लाइक वो कितना डालना है, वो स्केलर वैल्यू से हम डिफाइन करते हैं। तो स्केलर्स आर ऑल्सो इम्पॉर्टेंट। ठीक है, हाउ टू थिंक अबाउट स्केलर? स्केलर इज सिंगल न्यूमेरिकल वैल्यू, जस्ट अ नंबर। एग्जाम्पल 5 - 3 1 e raised to the power -10, etc. Think like learning rate, model error, control signals, measurement values, and scaling factors. We can think about like scalar for these things. Mathematical formulation: a scalar is usually denoted by lowercase a, b, c. and or Greek letters like alpha and lambda. This is a lambda. So let's say consider a simple linear model y is equals to 2x. Here x might be a vector or input feature, right? Let's take an example of a simple linear model y is equals to 2x, right? That's our linear model, linear regression model. That's basically it. Like the equation is very large, and everything is very complicated, but the model works on this principle only. We are basically creating a simple line out of data. So y is equals to 2x is a simple linear model. Here x is a vector, right? A vector of n data points, right? And 2 is a scalar that does exactly one job. It scales the input, or we can call it a weight weight and biases. So summary: a scalar is a single numerical value. It represents magnitude and quantity only. Scalars control scale, error, and learning behavior in ML models. Small changes small changes in scalar can have massive effects. Okay, now let's come to the next part. So we there are basically three parts: scalars, vectors, and matrices. So now we have come to the vectors part. If you strip away, okay, so अगर आप so basically if you strip away the frameworks, GPUs and everything, ठीक है, like machine learning models do only one thing repeatedly. They operate on vectors. यही मैंने आपको बताया था. They all data points, actually every data point is converted into a vector, is transformed into a vector, and the collection of vector is transformed into a matrix, and we perform matrix operations on the vectors, right? So every row in your data set is a vector, every image becomes vector, every text embedding becomes vector. So understanding vectors is the point where machine learning stops being a black box and starts looking like data moving through space in very specific ways, like space of n dimensional space that we have just talked about. So n dimensional space is basically the features, the number of features, the more number of features, the more dimensions. And when we perform the matrix operation, the dimensions also change. So data is moving through the dimensions, and that's how it all, in the bigger picture, it works, right? So core concept: a vector is an ordered collection of numerical value that represents magnitude and direction. Example: a car is 60 km towards east. 60 km per hour. Sorry, a car speed is 60 km per hour towards east. So vector, what is the difference between like if we compare the scalar with the vector, scalar has only the magnitude, राइट? जैसे मैंने भी आपको बताया कि लर्निंग रेट में एक वेरिएबल होता है एक मशीन लर्निंग सिंपल लीनियर रिग्रेशन मॉडल में, जिसके अंदर हम उसकी वैल्यू इनपुट करते हैं. दैट स्केलर इज एक्चुअली रिस्पॉन्सिबल, लाइक द स्केलर्स आर दी कि कितना मसाला, कितना लाइक आपको कितना अपने नमक डालना है, कितना, 2 चुटकी या 4 चुटकी, तो वो दोज आर दी मैग्नीट्यूड, right? And the vector represents the magnitude as well as the direction. And in the context of machine learning, what does it mean by direction? So let's say in Cartesian plane, we are representing this vector. This is a vector. Vector has a starting point, a tail, and an arrow. Arrow represents where the vector is pointing towards, right? So now if you see this example, we have xy plane, and there is a vector v. So the arrow points to the point of 4 comma 0, right? Here the length is 4, that is the magnitude, and direction is on the x-axis, right? that is just to bring the old mathematics back. That's how we represent the vector, right? We are only talk today we are only taking this I have only prepared for this so far, but let's see. Okay, so this is the vector. I will explain it again. So here we have an xy plane, and on the xy plane we are representing a vector v, and the vector starts from the origin and ends to the and pointing towards the point 4 comma 0. So the length is the magnitude of the vector. What is the length of the vector? And the direction is on the x-axis. Direction is the x-axis, on the x-axis. Or in the Cartesian plane, if we don't know, let me in the Cartesian plane, this is called first quadrant. Okay, like if someone is thinking about, let's say, what if the direction of the vector is like towards this. So that's how we understand the direction of the vector, in which quadrant it lies. So for example, let's say there are more than three dimension. How will we define, like, in which dimension it is, where is, what is the data point? We cannot even imagine. We can't even imagine beyond the three dimensional space, like how the vector is. So that's why it is doing a fantastic job. They are very, very interesting. So that's this is the first quadrant, this is the second quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. In the Cartesian plane we have fourth, second quadrant, and this is the third, right? इसको हम क्वाड्रेंट से रिप्रेजेंट करते हैं, और it, and usually this is the x-axis, and this is the y-axis, and this is a Cartesian plane of R. Let me check if I can. R2. This is a Cartesian plane of R2. Right. A vector can be written as and denoted by font X. So everyone understands so far, uh, like what is a vector and how does it relate to the machine learning. This is what I am covering today. I am only making it sense to the larger audience, like those who have not from the background of the mathematics. Why are we studying it? Because linear algebra basically is the three things that we need to understand. It's a branch of mathematics that deals with vectors, matrices, and operations on them, right? So we are making sense of vectors. What are the vectors, and how does it relate to our data, right? So I have given an example of a linear regression model where input feature of house size is a vector itself, right? So if I want to plot this data, if I want to plot this data in a two-dimensional space, I will use this vector to plot my to represent my data points. And and in linear algebra there are basically three parts, three things that we need to understand. First are scalars, second is vectors, and third is matrices. That's all. ये क्या होते हैं, क्यों होते हैं, कैसे होते हैं, किस लिए होते हैं, और ये सब जानना है हमें. इससे ज़्यादा हमें ना, हमें इसमें आगे जाना है ना हमें पीछे जाना है, हमें बस इतना ही समझना है, राइट। लाइक अगर मैट्रिक्स की बात करते हैं तो फिर मैट्रिक्स मल्टीप्लिकेशंस, मैट्रिक्स ऑपरेशंस वगैरह वगैरह, राइट। और फिर हम उसके बाद आ गए थे स्केलर्स एंड वेक्टर्स पे और रिप्रेजेंटिंग वेक्टर्स, वेक्टर नोटेशंस एंड इंडेक्सिंग वेक्टर्स, दीज वर आवर नेक्स्ट टॉपिक्स. So we are understanding the vector. I have given you this example. So a vector can be written as an x where each point represents a data point, right? And n is the number of, where here x is a vector. So that's how we in mathematics, uh, whenever we define an equation, we use this uh, we use this template, or we use this, we basically, that's how we define our equation, right? This is something that is written here. I cannot type it, मुझे इसका स्क्रीनशॉट लेना पड़ा, अब मुझे इसे एक्सप्लेन करना है, तो दैट्स हाउ वी एक्सप्लेन इट. x arrow to the a vector containing n values representing a single data point. X belongs to Rn, means x is a vector of Rn plane. Rn माने how many data points, or how many features, how many dimensions, कितने डायमेंशंस के वेक्टर है, राइट. और बहुत ही इंटरेस्टिंग होने वाला है अभी अभी जैसे, राइट. सो एक्स आई इज अ स्केलर, एक्स आई इज अ स्केलर. एक्स आई माने x1 x2 x3, सो एक्स आई इज अ स्केलर एंड n इज द नंबर ऑफ द फीचर्स, n is the number of the features, right. And xi is a scalar but can be a vector also, right. A vector containing multiple vector, nested vectors, right. So where xi can represent a vector also, right. A vector can be represented as v, ऊपर थोड़ा सा ऊपर मतलब arrow, यानी कि this is a vector, and in the subscript we define a b c, vector is equals to में the data points. That's how we define the vectors. And indexing in vectors. So the standard mathematical notation indexes in vectors from I is equals to में 1 to I is equals to में n, right. So AI could indexing of vectors, right. So indexing of vectors माने like indexing of elements in a list. So we are basically indexing our vectors, right, like in the same way we use in our database. So like the standard mathematical notation indexes n vectors from I to I1 to n, meaning AI could be the ith element of a vector or ith vector in a collection. Okay, so let's say we have a vector A in which we can have a vector A which represents a collection of data points. How many data points? N data points, where each data point is a scalar, that is 2 3 7 8, or till the n data points. This can also be a vector, whereas capital A vector is a collection of vectors itself. So capital A vector can be also an collection of vectors, where I at every index there it contains a vector of a single feature. So these represent the number of the features. So A1, A2, A3, these are the individual vectors of each features, right. So A1 can be this. So this vector is here, and similarly we have more vectors, right. The meaning of course the changes, but we can do this. Vectors containing the list of vectors, collection of vectors, right. ठीक है. And right, so A1 can be A12, A132, A1n, So that's how we index the a1. Let's say we want to find out a particular data point in a vector a. So how will we find out? We will say a dot a1 vector dot a11 or a12. So that's the individual data point. Dot, please don't consider this as a dot product. I'm just only trying to make sense the hierarchy, like how the indexing works. Every vector contains every bigger vector contains small vectors. And yeah, so that's my today's topic for the linear algebra. Or I have also opened this book for everyone. uh, so I think we can complete every chapter on on 1 or 2 sessions, 1 sessions at max. And basically sir has explained this much, like a 344 pages in 1 hour, right? So I will try to explain, pick one chapter, show everything, and give it a example. That's how we can go. Let's see how it goes. I will prepare this document till the first part and the second part. Tomorrow we can also join. जितना हो जाएगा उतना कंप्लीट करेंगे.
Sorry, Manshu, I have one question regarding the RNA vectors. Actually, I'm doing really, I saw the videos 2 times, but I'm not understanding what is the RNA vector. Sir are taking the values from somewhere, and I'm not understanding where these matrices are coming. I tried to read this book as well. The book is another way for big lambda with the gross big and the small letter lambda. They are asking some question. I'm feeling I'm not able to understand this thing. Can you explain me little so I can understand?
Hello everyone. Like I can start with that. Like where are the matrices come from? We can do a small exemplary thing. Like what do you say, Himanshu?
Ha, please, Satyam, please, if you can answer the query, please. Simran, I just want to confirm your that question. What was the question? Like, what are you not understanding exactly?
RNA vector net vector decomposition is the question about cell is taking the values by, for example, the I, capital I, 2112. Where is getting these values? And he and book
So basically,
and
right, right, right.
and one question is book is creating the lambda, capital letter and the small lambda. What is the difference between both, and how it will work? I'm not understanding this thing.
I
I
can
tried
totally, yes.
to take some questions,
I
but
can
it's
understand what is,
confused.
yeah, right, right, right. That's okay. That's normal, Simran. Don't worry. This will resolve very soon. Okay, so it's okay, sir. So मैंने आपको बोला ना, like sir has explained a bit too much in a very short period of time. So that is very difficult to understand कि where are these values coming from. In one book it is lambda, other book is something else. So that's okay, Simran. We'll find the answer very soon. Okay, Satyam, please. Satyam has also prepared something to share with us. So we can. Satyam, you please take forward. Okay.
या श्योर हिमांशु सो मैंने ज़्यादा कुछ नहीं आज मेरे को लगता है कि बहुत ही मैंने जो पढ़ा है मतलब वो थोड़ा सा मैं बताने की कोशिश करूँगा अगर आप लोगों को कुछ ऐड करना हो तो आप कर सकते हो तो हम एक एक एग्जाम्पलरी इक्वेशन लेते हैं एक लीनियर इक्वेशन 2x - y equals 0 and minus x plus 2y equals 3. So ये दोनों लीनियर इक्वेशन है, राइट? हमें पता होगा लीनियर इक्वेशन क्या होती है, मतलब यहाँ पे लोगों को थोड़ा पता ही होगा इस बारे में। अगर नहीं भी पता है तो अपन इस इक्वेशन के थ्रू समझ जाएंगे कि एक लीनियर इक्वेशन क्या होती है और वो कैसे काम करती है। तो 2x माइनस वाई इज इक्वल्स टू जीरो कब इज इक्वल्स टू में जीरो होगा? x और y की ऐसी कौन सी वैल्यू रखे कि वो इक्वल टू जीरो आ जाए? एक क्या सॉल्यूशन प्रोवाइड कर सकते हैं हम कि इसकी वैल्यू जीरो आ जाए? क्या कोई गेस करना चाहेगा?
Matrix, we are dividing, for example, multiply by 2, it's like that, rows and columns like that.
Yeah, but like I'm asking about what should be the value of x and y so that this equation is uh, turns out to be true. So that this
Zero.
sides turns out to be equals to zero.
We have to keep zero x and y both.
Yeah, we can do that. That's a good point. We can do x zero and y zero. That will become
And the value of y is half of x.
okay. We can do this as well. We can give y two and x a one. Now let
Sorry, vice versa.
yeah. Now let me draw this. So we have two solution. We have multiple solutions of it, but like on this graph, if x is equals to 1, here is 1, and y is equals to 2, then uh, it will be a solution to this equation, the first equation. Now, now if we do the same with this, how will the left hand side will be equal to the right hand side? What will be the value of x and y? Let me draw it. Let me draw the first equation we had. I'm sorry, I'm not pretty good with this, but like yeah. Now, what should be the value of x and y in this equation so that it is equals to 3? We can do it like we can like do minus 1 and 1, so that minus 1 and minus equals to 1, and 1 plus 2 is equals to 3, right? Now if I plot this on the graph, this is minus 1 and somewhere here is 1, right? See what is happening. It is intersecting right here. What was this point? This was 1 comma 2. Now why we are calling it a linear equation? Are anyone have a, I mean, anyone want to guess it? Why we are calling it a linear equation? This and this. Anyone like कोई भी guess कर सकता है, ऐसा कोई वो नहीं है, मतलब this is not like some rocket science, but like मैं बता देता हूँ, कोई बात नहीं। ये क्या, ये जब हमने इसको इस इक्वेशन को ग्राफ पे प्लॉट किया, like 1 and 2, we had this line, right? And then we had a line. This was the line, right? Right? We have a linear equation. We have a linear equation which has a solution point named as 1 comma 2, where x was 1 and y was 2. Same goes with this. If we want to prove this equation right, we have to give it like x is minus 1 and y is 1. तब भी हमारे पास एक line आई. This was the line and it was intersecting right here. अब मैं now I want to like uh, now I want to break these two equations into equations. How I will do that? What I will do is I will like write it minus 1 minus 2 minus 1 and minus 1 and 2. Now where are the x and y's? Here are they. We can write it x and we can write it right here y. Okay, and like I'm what is I will tell you what I'm doing here. So above are two different linear equations which have a same solution 1 comma 2, right? We have a same point here. What I'm doing is I'm breaking it down to a matrix. Consider them x and y's are as data points. Consider them as a data point. And what I'm doing here is I have converted them into a matrix. 2 minus 1 minus 1 2, and then I have taken the coefficients x and y's. Here are the x and here is y, which is equals to 0. Now, Himanshu has already told us in previously, like some minutes back, that we just need to know about how matrices are getting multiplied, right? So, if I can call it x, like this is an equation again. We are having an equation again. So like why I'm sharing this is because like each of these equations are converted into matrices first, and then that's how we are proceeding. Like this is a very general phenomenal thing we need to do in whole ML, I guess, like especially in machine learning. uh, Later on we will be learning from our respected teachers about how to build an LLM and how they are working, and they work pretty much on weights and biases and how they are interacting with each other, and then there will come interference. But basically, just I want to just share these things, that these are two linear equations and I have converted them into matrices, and we have some kind of general point here. So that's how like we will gonna proceed. We have one more, I can tell you one more thing. What we had done right here is a
Satyam, just want to ask one thing.
yeah, yeah,
So basically, the goal of these linear equation was to find the values of x and y, right?
yeah,
Right. Okay. So like we are converting this into the matrices form to get the values of x and y.
yeah, 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 yeah,
Right.
yeah.
Okay. Okay. Thank you.
So what this is a row picture, right? Y rows we have converted them in rows, and like this graph is known as a row picture. We can do divide this in a column as well. I will tell you how. And correct me if I'm wrong. I'm also a learner, just trying to figure out how maths work. We can write it like this as well. Now, this is also satisfying our both of the equations we had above. Like, like we had a point here, right? 1 and 2. If the values of x and y's are 1 and 2, the whole equation is still true. And like we can like graph it again here. It will be column 1 for 2 and minus 1, and minus for minus 1 and 2 there will be column right here, like minus 1 and 2, and like this is like column 1 for 2 and minus 1. So basically I just want to share this, that there we had like two imaginary linear equations which we can plot on graph, and like then we can break it to in two forms. One is row form, in which like I have divided in it a matrices named as 2 minus 1 minus 1 2, and then we had a x and y in a different matrix, 1D matrix, and like this is like a row form and this is a column form. So that's how we divide like matrices. Now coming to the question that Harmanji's asked, what is eigen vector and how does they work? So before starting what is eigen vector, we need to like learn about non-zero vectors. So when a linear uh, okay, let me start from here. What is the key characteristic to identify what is an eigenvector or a vector? So an eigenvector is basically they have a main property of direction that remains the same after the linear transformation. Now, what is a linear transformation? I've tried to explain it right here. These are two linear equation and we have converted it into a matrix. Uh, a linear transformation can be a transpose can be an example of a linear transformation, or two matrices multiplying with each other giving us a different matrix which can further divide it, which can further convert it into a linear equation. So whenever a linear equation is getting transforms, and if the direction is remaining same, we have an eigenvector. It can be flipped, stretched, or shrunk as well. So that is the first main characteristic of an eigen vector. Now, how it is associated with a matrix. An eigenvector can be defined with a relationship. It has a specific relationship to a square matrix because it is not changing any direction. There are no direction which are getting exchanged. Now, ma'am has asked like what are the symbols and how we can like know about them. So there are two things. One is eigenvector and another is eigenvalue. So eigenvalue is basically lambda. This is eigenvalue, right? IGEN. This is eigenvalue. And um, how we define and like how we define eigenvector, it's basically just this v. This is an eigenvector. Now, like there are different kind of eigenvector evaluations, which what I have learned today was the fundamental equation that defines the relationship between a matrix and an eigenvector. So let me just erase this first. Let me just come down for a new board. Yeah. I haven't also learned much, but like whatever I have learned, I can like share it with you guys. So basically, today I learned about eigenvector equation. It is a fundamental equation, and what sir was telling us, we need to like first learn about this, which sir has already told us. So like I'm just redefining what he has told. So this is a fundamental equation that defines the relationship between a matrix and an eigenvector. So the equation is this: AV is equals to, this is the equation. What is A? It is an square matrix. Anything can be it, like 1 minus 2 minus 1 2. Just an example I'm taking. What is V? V is a non zero eigenvector. Okay. What is lambda? This is eigenvalue which I have already told you, but it is corresponding to the eigenvector we have in this equation, a corresponding eigenvalue. All right. Um, Now we can also rearrange the equation which I have written here. We can also write it like this: A minus lambda I V equals 0. What is I? I is an identity matrix. So what is an identity matrix? Like किसी को पता है तो वो ऐड कर सकता है.
Diagonal columns are one, right? And
या सो
rest are
आइडेंटिटी मैट्रिक्स का एक बहुत ही कॉमन एग्जांपल, मतलब एक चीज होती है, ये डायगोनल सेम होते हैं, वन होते हैं. दिस इज एन आइडेंटिटी मैट्रिक्स, राइट? Himanshu, if I'm telling anything wrong, please you can correct me, I'm also learning.
Right.
So we can write the eigenvector equation, the fundamental equation like this as well. So I think Herman, am I able to answer your question?
Yeah, I'm understanding.
Okay, okay. So yeah, that's from my side, guys. Like I've read I'm following the MIT course that like our sir told us, which is a very good course. It's the same the author of the book that Himanshu shared. That's the same guy that is teaching. Very learned, very good guy. So like I've done some part of it, and like I've prepared much more notes. We can like carry on uh, yeah, tomorrow as well. I'm going to cover the whole linear algebra because like as Himanshu shared with us that like to understand how ML works, we need to like there are four pillars for that. So one is linear algebra, and it has already started, and we have our classes on Saturday and Sundays only. So the whole week is like empty. So I'm eager to like share what I have learned. So I will be like doing it with Himanshu only in this group, and like we can also make another group if you guys want to for maths, for learning maths. But I think this group is good as well. So like I will be sharing what I have learned, all of it, all of my notes on this like linear algebra, and I think Himanshu is taking care of like the numpys and pandas and scikit-learn and the other part of it. So I can do that. Like you guys can also like contribute to us. Like we are only learning here and we want to learn the best.
Yes, yes, Satyam. And I also want to add something on in it. Like everybody is coming from different background. Not everybody understands every part of the production machine learning model. So there is a whole huge team of data engineers, data scientists, machine learning engineers, uh, uh, right, and the analyst part and the data scientist part. So every job scopes covers the different aspect of machine learning. So if we want to make sense, or we can just we can just contribute to the community with every any kind of knowledge that you think is and would be an advantage to know. If you know, so, right, if you have anything to share, please, you guys are always welcome to present before us, and we can continue also further. That is completely fine. And and the linear algebra part. Okay, so right now we have just understood what is linear algebra, and what are the vectors and matrices. That's how we should go, and that's how we will go every day, every time. And so what I'm thinking of, I will cover. Okay, let me stop the recording first. This is that is the today's part.